Hi team, it's biomechanics time again, and today we're going to talk about the principle of projectile motion. We often talk about a body or an object flying through the air, and these words can be used interchangeably, although biomechanic scientists will generally use the word body, even if it's referring to a ball flying through the air. So it could be a long jumper trying to get as much distance as possible. Equally, it could be a tennis player hitting a tennis ball being the projectile. When we talk about projectile motion, we talk about flight path. And the flight path is what we call a parabolic curve. You may have come across this in maths or physics or science. So a parabolic curve, it has a vertical component and also a horizontal component. That curve won't necessarily look like that curve there. Sometimes it might look like this. Sometimes it could look like this. Other times it might look like this. So it depends on what we're trying to achieve with our object, with our body that's flying through the air, whether we want to have a big vertical component or a big horizontal component or a good mix of each. So this one here, this could be an example of a high jumper, where height is the important thing, and so you want a high vertical component, but you don't necessarily need much horizontal distance gained. Whereas if we're thinking of a golfer, when they tee off, they want to get as much horizontal distance as possible, whereas height isn't the be-all end-all. However, height does come into it. So we're going to have a look at the 6 factors that impact on an object's flight. So we're going to talk about speed of release. Basically, the faster that an object can be released into the air, the further it will go. So faster is going to equal further. And think about beginners compared with experts. Perhaps think about a shot putter, and think about some of your high school students who don't have a lot of experience, and compare them to someone like Valerie Adams when she's shot putting, and you can see the speed of release is hugely different, and it definitely has an impact. We also talk about the angle of release. Now, the biomechanical scientists have found out some interesting things. They reckon the optimum angle is a 45-degree angle. But then it actually depends upon what the objective of the projectile is. So for instance, if you're wanting a lot of height, and you could do this with a hose, test out this experiment, you could perhaps have it at about an 80-degree, and it'll go up through there, and then it'll come down with not much distance. Whereas if you have something that's closer to a 30-degree angle, it'll go out, and it'll gain more distance. So angle of release does have a lot to play. So they talk about 45 being the optimum, spelled incorrectly. A higher angle will have greater vertical and less horizontal, whereas a lower angle would have less vertical but greater horizontal components, so more flight. And if you have a look at some research, sometimes that 45-degree isn't always the optimum. I was having a look at the long jumper, they talk about sort of about a 30-ish, 33, 32 degree angle of release. I was having a look at high jump. I was thinking, oh, would it be about 75? The biomechanics reckon it could be closer to sort of 45, 47. So that's quite interesting. But generally, we think about higher angle will give greater vertical component, less horizontal, lower angle, less vertical, more horizontal. So speed of release, angle of release, and height of release plays a part. This is going to get a bit messy, isn't it? So height of release. If you can be, now a golfer would, let's talk about a golfer. If a golfer was on an elevated tee and was going to hit the ball, their ball will go further than their buddy who's hitting it off at ground level. So height, greater height of release will equal greater distance. So how can you change that with the human body? Have a think about whether your athlete extends fully. So again, think about your shot putter, and when they actually go to release the ball, are they fully extended, or is there still flexion in their knees and their hips, and perhaps within their arm at their elbow? So there are things that they could do to improve their height of release, even though they can't grow. Now, there are three other things that will come into play. One is gravity. So obviously gravity, as soon as something goes into the air, gravity is going to push it down, and that works at 9.8 meters per square meter squared per second. So it's going to push it down. So gravity. There is air resistance, and then particularly you can think about if you're outside and you've got the wind, so that's going to impact on the flight of an object. And the other thing that will impact is spin. So spin's quite interesting. We often think about sort of tennis, let's spell it right, thinking topspin and underspin, or a slice. Comes into basketball as well. Topspin, we're spinning this way, so over, and what happens is the object will fly, and it will suddenly drop, and it will hit the ground hard and bounce up. So that's great in tennis, because it'll often drop just before the baseline and then bounce up really hard for the opposition to get back. However, if you're shooting a basketball and you put topspin on and then it hits the backboard, equally it's going to hit that board hard and then bounce straight back off. Whereas underspin, so spinning under, it's going to soften things. So with a slice, it will hit the ground softly and it will just jump up a little bit, or kind of skid. Off a backboard with basketball, it would just hit the backboard gently and hopefully just kind of flop into the hoop. So there you go, 6 components that impact or affect a body or an object's flight through the air. All of that equals projectile motion. Go and find out about some other things. Magnus effect, have a look up, spin, have a look up Magnus effect. It's really interesting. There's some cool videos. Yeah, that's enough. Okay, good luck.